Alright, so we're looking at a limit problem, a limit as x approaches infinity, um, specifically the limit as x approaches infinity of x squared over the square root of x to the fourth plus 1. The first thing you generally want to try when you're doing limit problems is just direct substitution. In the case where x approaches infinity, it doesn't always work. It doesn't usually work. It doesn't look like it's going to work, but we'll try it anyway. So we'll get infinity squared over the square root of infinity to the fourth plus 1. And in this case, when you're dealing with numbers like infinity, constants like these, this 1 doesn't matter at all. It's negligible. And we're going to end up with infinity squared over the square root of infinity to the fourth, which is infinity squared over infinity squared. Either way, there's an infinity in the numerator and an infinity in the denominator, and that's all that matters. That's not defined, and that's not what we're looking for. So what we're going to want to do is try some algebraic manipulation. So we'll write the problem. The limit as x approaches positive infinity of x squared over the square root of x to the fourth plus 1. So what we're going to want to do is find the highest degree in this, and that's going to be 2. We've got x squared here, and we've got x squared here. It's just written differently. The square root of x to the fourth is x squared. So what we're going to want to do is multiply both the top and the bottom by 1 over x squared. Over 1 over, and we'll just rewrite it. We'll write it in the same way this x squared is written, even though it's an x to the fourth. Square root of x to the fourth. So this is x squared, and this is x squared overall. This is 1 multiplying by 1. We're not changing anything. Is equal to the limit as x approaches positive infinity of x squared over x squared all over the square root of x to the fourth over x to the fourth plus 1 over x to the fourth. And that is equal to the limit as x approaches positive infinity of 1 over the square root of 1 plus 1 over x to the fourth. And the reason why we did that is because that simplifies the problem when we get to the direct substitution. So I'll rewrite it so we've got some more room. The limit as x approaches infinity of 1 over the square root of 1 plus 1 over x to the fourth. All right, it's getting a little small there. And now we're going to do the direct substitution. So with direct substitution, we get 1 over the square root of 1 plus 1 over positive infinity to the fourth. When you raise infinity to any degree, it's still infinity. So that's just going to be infinity. And 1 over infinity, anything over infinity, is equal to 0. So any number over infinity equals 0. So what we get is 1 over the square root of 1 plus 0 is equal, and so what we've got is square root of 1 plus 0 is 1, square root of 1 is 1. So we've got 1 over 1. So overall, the answer to the limit as x approaches positive infinity of x squared over the square root of x to the fourth plus 1 is equal to 1.